All right, today's Math and News. I am very excited to have Elaina in studio with us today because you are a meteorologist.
A meteorologist.
And where are you a meteorologist at?
KGET 17.
And I would like to say thank you to TV-17 because you guys recently had us on to help talk about the upcoming season 24 of Do the Math. So I want to thank you for that. And we were going to have you on anyway because I think that what you do is so cool.
Thank you. I do too.
I mean, being a meteorologist, so exactly, because people were like, all right, well, I've heard of meteorologists. I know it kind of has to do with weather. So kind of briefly, what is your role? What do you do as a meteorologist?
So I study meteors, which you would think is outer space, right? A meteor is a rock that falls from space. A meteor is anything that falls from the sky. So
I did not know that.
Right, fun fact.
Okay, so anything.
Anything. A raindrop is a hydrometeor. I once had a kid in a classroom ask me, so if a plane falls from the sky, I'm like, well, one, that's sad, and two, that's not a meteor, but if you have something natural, right? If you have something natural, a raindrop, a hailstone, that's a hydrometeor, and I am a meteorologist.
Okay. Well, one of the fascinating things is hail.
Yes.
Okay. And I know you've got a graphic here. Well, I think we'll go ahead and we'll have to put that. Do you want that at 3 or 2? I think we're always good at 3.
3. So this is an old box because I like to recycle, and I found this at the dollar store, and so I thought it was just neat to go through, show you all the different types of clouds that we have. But at the very top here is a storm, and that's when we have all of that updraft that's tossing the rain above the freezing layer, and it's starting to create hail. So this is my hail kit.
All right, so this is your hail kit. And in Bakersfield, we don't usually see much hail.
Not much.
Because usually we don't even see much rain.
Exactly.
And somebody had said, oh yeah, don't you remember it rained the other day? And I go, you mean the sprinkles that barely covered the ground? That's
just
not
kind of pushed
rain.
around the dirt on your car.
But there are times when we get rain,
Yes.
and it's not a good thing if we get a lot of rain because the lack of it makes it more difficult when we do have some.
It can.
But let's talk about hail. How does hail form? And what are the different types of hail or sizes of hail?
Yes, so we'll start with, I have a little marble here. So you have a raindrop that's falling, right? But a thunderstorm, as I mentioned, has updraft. So it's going to push it above the freezing layer. The camera's trying to follow me. And it's going to get tossed around. And just like the rings of a tree, if you cut a tree down, you see the rings.
Right.
That's how a hailstone forms. Each time it drops and gets pushed back up, a new layer of ice will freeze.
So if a kid was able to grab one of those and cut it in half, they could tell basically how many times it went up and down.
Yes. Exactly, and so
cool.
it keeps getting bigger each time. So this is typically about as big as we'll get in Bakersfield, because with our mountains, it kind of stops that thunderstorm development. When you're in Oklahoma and you have long training thunderstorms, they have hundreds, if not thousands of miles to build, you can get very large hail. Here at home, we don't get much. I have seen a few times from the National Weather Service where they will call for penny-sized hail.
Okay.
That's pretty big, because again, this is a flat penny, but we're talking about diameter for size. So make this a sphere and you see how big it could be. Then as you keep going, we go up through all of the coins. They skipped dime because it's smaller than a penny.
It's smaller than a penny, right.
So we'll go to nickel.
Worth more, but.
Worth more. We'll go to quarter.
Okay.
We'll then go to a $50. It took me a long time to find this. Aren't many in circulation anymore. Then we jump to, I want to make sure I get this right, a ping pong ball.
Now that's a considerable sized piece of hail.
Again, this is very light, but imagine this is solid ice that's falling, and there's not just one.
So it's damage to property.
It is.
A lot of times.
This can be very scary. After a ping pong ball, it goes to a golf ball. This is my daughter's, that's why it's pink. Then we're going to go to a hen's egg. And I love this because, again, we're talking about the diameter. So we're talking about this perfect circle for size. But this also shows you that hail isn't always perfectly round.
That's what I was going to ask. Does it have to be perfectly round? And they're not smooth either.
They're not smooth either because they're being tossed around in that freeze.
And they're also collecting things in the air at the same time. So they could be different colorations in them and things like that. And you'll see whatever's in the air is going to be in that hail.
One of the grossest hail I ever saw, usually it's covered in dirt or grass that's been churned up. One time it was mosquitoes.
Whoa, they caught
Pretty
those.
Gross, yeah. And then we will go to a tennis ball. Again, imagine this is full hail. Have you ever been hit with a tennis ball? It hurts. This is hollow. So if it was ice, that'd be awful.
I've been hit with a baseball.
Hit with a baseball?
Yeah, so
Again,
that's the next size up, of course. We're going to go for the bigger one, right?
This is dirty because my dog got it. Softball. So this is about as big as we've ever recorded, and we'll show you that in a minute. But I also wanted to show you that for the National Weather Service, their size goes up to a grapefruit. So my little soccer ball here shows you that it's just slightly bigger. The record hail is more than 7 inches in diameter. It fell in not Oklahoma, but South Dakota.
Okay.
So you have to get that perfect environment. You have the warm, moist air crashing in with the dry air, and that clash makes the storm very angry, and so it builds, and they had such an updraft that the ice kept forming. So this is record-setting hail back in Vivian,
we can see
South
that right
Dakota.
there, down on the lower left-hand side, the diameter 8 inches, and you take a look at that thing. That's pretty drastic.
Yes.
And I mean, it damages a lot of property, but that would damage you also if you got hit with something like that.
Unfortunately, yes, people can get very hurt in hailstorms, and so that's why we always tell you to find shelter, duck cover, and hold on. If there's lightning around, you don't want to be near a tree, but if it's just hail, there's no rumbling thunder, being under a tree could help.
Because I know when it rains and we're at school, I'll tell the kids, hey, go outside, take a look at the rain or whatever real quick, but then when it hails, I definitely want them outside to see it.
Yes.
But we have an overhang at the classroom also, so they can be underneath that, but be able to see that hail. Yeah. And it's, the smallest one you had, obviously it isn't very big.
Yeah, you have, again, the marble is pretty big. Usually we'll get little pea-sized hail, but encourage your kids to go out and pick it up afterwards. Feel if it's solid, that's hail. If it's kind of slushy or snowy, that's graupel. It's
and I do remember you guys talking about that
Yes.
one time on the news. I do remember you guys talking about that. Now, another thing that fascinates me, we got about a minute left, is clouds.
Clouds.
And the different types of clouds and where they form. And I know that when we're looking at clouds, sometimes you'll see big puffy clouds, but they're absolutely flat on the bottom because of the layers of atmosphere, correct?
That's exactly
So tell
right.
us a little bit about that.
So that's what we call the LCL, the lifted condensation level. So there's moisture below, but it's not condensing until it hits that mark.
Okay.
And typically those big puffy cumulus clouds are after the end of a storm. So they're fair weather clouds, showing you that there's still moisture, but the angriest part of the storm is done.
So when we see it coming in, are those also the same types of clouds or different ones because they're coming in as opposed to
going out? It depends. So cumulus clouds can just float in from the ocean on a fair weather day, but typically for us here in Kern County, what we see coming in are gray. Those are holding more moisture, and those are nimbo clouds, nimbostratus,
Right, 'cause I was going to say
nimbocumulus.
nimbostratus and stuff like that. What about cirrus?
Cirrus are thin, wispy clouds. Think of cirrus as the Latin word for curl. So they're just kind of curly, happy clouds, usually very high in the atmosphere.
I love clouds.
I do too.
I love hail. I love weather. It's something that we don't usually get a lot of active weather in Bakersfield.
Yeah.
So kind of quick, where would you need to go to get, I mean, you don't want to be in Tornado Alley all the time and
Right.
stuff like that, but a lot of places have more consistent weather activity, let's say.
Honestly, it's changing. Our climate is changing. So we always had Tornado Alley was Oklahoma, Kansas, maybe northern Texas. Now we have Dixie Alley, which is the southern states. Mississippi, Alabama can get very severe storms. Ohio River Valley is now getting more and more severe storms. So really anywhere could get hail. But to get hail like this, I think you need to be in the wide open plains.
Yeah, I think I'll be avoiding that also. Anyway, Elaina, thank you for taking some time to come visit us today. I know that we certainly do enjoy everything that you do on Channel 17 with informing us about what's going on. And we'll thank you with your time coming in and talking about the diameter and the size of different types of hail.
Yep.
And speaking of hail, do you know there are hail numbers?
I do.
Well, you know what? We're going to check it out right now. Our next mathematician, Lothar Kolatz, and he had a conjecture, which is like a theory, a guess, that any number will always end up in a loop ending at 4. So, let's see exactly how this works. So you can take any number you want. So we are now in our 24th season, full season of Do the Math. So, simply, if the number is even, divide it by 2. If the number is odd, multiply that number by 3 and add 1. So we'll take the number is even, so we're going to divide it by 2. So we're at 12. The number is still even, we're going to divide it by 2. We're at 6. The number is still even, we're going to divide it by 2. We're at 3. Now, the number is odd, so we now have to multiply this by 3 and add 1. So 3 times 3 is 9, plus 1 is 10. All right, we're even again. So we're going to divide it by 2, we're at 5. Multiply it by 3, 15, add 1, we're now at 16. If we're at 16 and we divide that by 2, we're now at 8. We divide that by 2, we're at 4. Divide it by 2, we're at 2. Divide it by 2, we're at 1. We're done. The 4 is going to be the key number. So if we take this number 1 and multiply it by 3 and add 1, 1 times 3 is 3, plus 1 is 4. We're going to be back in this loop again. So the number will always end at 4. So, all right, let's try another number. All right, let's just do one underneath that. We always love the number 23 here on Do the Math. So we'll start with an odd number. So, multiply it by 3 and add 1. 23 times 3 is 69, plus 1 is 70. The number is even. Divide it by 2, 35. Multiply it by 3. It says 90 plus 15 is 105, plus 1 is 106. Divide it by 2, 50 and 3. All right, now we're going to have to take that and we're going to have to multiply that by 3. So 159 plus 1 is 160. Divide that by 2. We have 80. Divide that by 2. We have 40. Divide that by 2. We have 20. Now remember, eventually we're going to get to the number 4, and we can see that that 4 is going to loop right back into a 4. If we're at 20 and we cut that in half, guess where we're going to be? At 10. So we can rewrite this all again, and we can see what the pattern is. It's going to go 10, 5, 16, 8, 4, 2, 1. So you can also take 23. It will also work the same way. His conjecture is that every single number is going to eventually end up in a loop, and 4 is going to be the key number. They had computers, and they worked out 300 quintillion. Okay, now 300 quintillion is going to have 20 zeros after the number 3. So if you write down the number 3 and put 20 zeros at the end of it, 300 quintillion numbers is how far the computer has gone so far, and every single number that they put into the computer eventually comes back to the number 4 and the loop. Collat's conjecture, it's not anything more than that because it has not been proven or disproven that it will go anywhere other than 4, but at this point in history, it is still going to the number 4. Sometimes you might be in class and they refer to these as Hale numbers, because in order to produce Hale, that atmospheric moisture has got to go up and down in the atmosphere in order to form hail, which is exactly what the numbers are doing, going up and down to eventually get back to the number 4. That is our guy Collat's and our mathematician of the day.